This is chapters 7.3 and 7.4, Theorems to Determine Similarity of Triangles. This will be the first recording, and AA stands for Angle-Angle Similarity Postulate, SSS stands for Side-Side-Side Similarity Theorem, and SAS stands for Side-Angle-Side Similarity Theorem. Now, these, particularly Theorem 7.2 and 7.3, the SSS and SAS, you have seen those or similar items in the Chapter 5 with congruence of triangles, except instead of sides being proportional, like they are for similarity, in Chapter 5 the sides were congruent. And so make sure that you understand that you've seen something like this, but it's not identical. The first similarity postulate is the angle-angle postulate. And you can see we have triangle ABC and triangle DEF. One is larger, one is smaller. And we can see that angle A is congruent to angle D, angle B is congruent to angle E. So if you have two angles of one triangle that are congruent to two angles of another triangle, then the triangles are similar. So we can write the similarity statement. Triangle ABC is similar to triangle DEF. Remember, when you write the similarity statement, you have to match up the corresponding angles. Okay, now we're going to look at the theorem. Now we're going to actually look at the checkpoint activities with this. And so for the checkpoint, this is on page 373, we're going to determine whether the triangles are similar and explain the reasoning. If they are similar, write the similarity statement. I'm going to ask that you draw your pictures in your notes. It'll only take a minute. Please use a straight edge. They come up much nicer. I won't be able to, but yours will be much nicer because it's going to be more useful to you when you are using it for homework, when you're using it during homework quizzes, and when you use it for quizzes. Initially, when you look at this, you can see that angle R and angle M are congruent at 80 degrees. So that's one angle. But then you see that you have a 65-degree angle and a 35-degree angle, which are not congruent, but they again are not corresponding. So if we use the triangle sum theorem, 80 degrees plus 65 degrees is 145 degrees. To get to 180, because all triangles' interior angles equal 180 degrees, it's 35 degrees. And then, I wrote it in blue right here, you can see that 35 degrees and 35 degrees are congruent. So I'll go ahead and highlight the two congruent angles. And when you have two congruent angles, then you can use the angle-angle similarity postulate to say that the triangles are similar. So in answer to their question, we wrote, yes, they are similar because a third angle can be found using the triangle sum theorem, so there are two congruent angles. And then they asked you then if it was similar to write a similarity statement. So triangle RST, now make sure you use corresponding points, is similar to triangle MNL. So R corresponds to M, S corresponds to N, T corresponds to L. We're going to go ahead and draw number 2. You can see that these are overlapping triangles. If you have a little trouble, it might help you to read example 2 first, because they actually show it being separated out and so on. So you might want to look at example 2 first. If this is adequate, then you don't need to look at example 2. Okay, so if you look at number 2, make sure you've drawn the pictures. One of the strategies in example 2 was to have you redraw the triangles separately. Now personally, I can see the overlap in my mind, so I don't want to redraw them, but if that helps you, you should do it. So GLH is a smaller triangle, and GKJ is the larger triangle. You can see there's still angle J is 27 degrees and angle H is 27 degrees. That may or may not be necessary for you. So we can see that they're going to share, we can see that they're sharing angle G. So they're sharing angle G. Okay, so those angles are congruent, and we can also see that they're sharing this 27 degrees, that angle right there. So there are your two angles right there. So in the angle-angle similarity postulate says if you have two congruent angles, then you can conclude that you have similar triangles. Now just a quick note, that third angle will also be congruent because any similar figure has congruent angles, and proportional sides. So we don't need 3 angles, but now that we know they're similar, we can conclude that the third one, the third angle, is in fact going to be congruent. Okay, so again, angle G is congruent to angle G. That's their shared angle. Angle H is of 27 degrees is congruent to angle J of 27 degrees. Again, I can see in my mind's eye that these are overlapping triangles. And if you have two congruent angles, then they will be similar. And that's the angle-angle postulate for similarity. And if they are similar, they wanted us to write a similarity statement. So triangle GHL, again, make sure you match up corresponding angles, is similar to triangle GJK. Again, G corresponds to G, H corresponds to J, and L corresponds to K. These two examples, 1 and 2, are using the angle-angle similarity postulates. What we're now going to look at is we're going to go to page 374, and we're going to figure out how to use the angle-angle similarity postulate, which tells us that two triangles will be similar, and we're going to use it to find out certain sides. So if we have an unknown side, we know that in any type of triangle or polygon, that they will have congruent angles and proportional sides. So we're going to use that thought with similar polygons, similar triangles, knowing that they have congruent angles and proportional sides to find unknown sides. So please, again, draw the pictures as we go. Okay, the directions say, write a similarity statement for the triangles, then find the value of the variables. First, we have to ensure that they are going to be similar. So we'll do that by writing angle A is congruent to angle D. This is given. Angle A and D are congruent. And angle B is congruent to angle E. So that's your angle-angle postulate, similarity postulate. So if it meets the criteria, meaning two angles are congruent of the triangles, then it will be, they will be similar triangles. So now we're going to write the similarity statement because that's one of the requirements. So triangle ABC, and make sure you match up the corresponding parts. So A corresponds to D, B corresponds to E, and C corresponds to F. So there is our similarity statement. There's one of the things it's asking for. It says then find the value of the variable. So once we know they're similar triangles, then we can know, so if the angles are congruent, again, if two of the angles are congruent and it's similar, then the third angle is congruent. If the angles are congruent, then the sides are proportional. And I want you to write something up at the top of your notes. Okay, in chapter 7.2, we worked on similar polygons. Triangles are included in polygons. It's a three-sided polygon. It's a closed figure and it has segments. Anytime you have a similar polygon, the attributes will be that the angles will all be congruent and that they will have proportional sides. So have that written down because then that tends to make more sense with what I just wrote. Take a minute, write it down, pause the recording, and then continue on. So we know if the angles are congruent, then the sides are proportional. So we're going to look at the large triangle to the small. It's always helpful to label large to small, L to S. And we're going to look at AB as compared to DE. This is a proportionality statement. And it's going to need to be equal to BC. BC is on the larger one, as compared to EF. The reason we're not choosing AC and DF, even though they could, since they're similar, they could be proportional, is there's no numbers given. So we're choosing BC and EF. So this is a proportionality statement. Now we're going to substitute in our numbers. So AB is 5. DE is 3, and BC is 15, and EF is an unknown, it's a variable y. Now, you could, you can use you could simplify sometimes. So sometimes you have to look at 5 and 3. If it can be simplified, you can. When you can't, then you're going to use the cross, so use cross product property. And that means you're going to multiply the means and the extremes. Some students think of it as like multiplying in an x. So we're going to go 5 times y equals 3 times 15. And 5 times y is 5y. And 3 times 15 is 45. We're going to divide both sides by 5 using the division property of equality. And y is going to equal 9. So we've actually used the angle-angle similarity postulate to help us find the value of y. We're going to do the same thing on 4. 4 is very similar, but we're going to have to talk about other congruent angles. So let's take a look at that. Okay, you have triangle ABD, which is the large triangle, and then you have triangle CBE, which is the small triangle. I highlighted the large triangle with blue and the small triangle with yellow. Just like over here, I highlighted the large triangle with blue, and I did the small triangle with yellow. So that helps you keep them straight. All right, we know that one angle is congruent, so we know that angle D is congruent to angle C. So angle D is congruent to angle C. Now we need another angle. And even though it's not given, it actually is there. Your angle B forms vertical angles, which is earlier in the book. I believe it's in chapter 2. And so we can actually go in and put that these angles are congruent, not because that was given, but because we know whenever you have angles that form that X that are directly across from each other, they're going to be congruent. So angle ABD, can't just say angle B, angle ABD is congruent to, and because A corresponds to E, I'm going to use that first, EBC. So now we have the AA similarity postulate. And we're able to write that triangle ABD is similar to triangle EBC, which is part of the directions to write a similarity statement. Now, because the triangles are similar, then their sides will be proportional, so we're going to use that knowledge to be able to figure out what the value of Z is. So we're going to set up small triangle, or large triangle, small triangle. Okay, so side AD is going to be corresponding to side CE right here in the large to small, and then in the large triangle AB, the side AB will correspond to the side EB. And then we're going to substitute in our values and use the cross products property. But before we use the cross products property, not that it would be too hard to use it without simplifying, let's go ahead and simplify 12/6, because any fraction can be simplified. So 6 over Z equals 12 is divisible by 6, it becomes 2. 6 is divisible by 6, it becomes 1. Now we're going to use the cross products property. So 6 times 1 equals 2 times Z. And that's going to be 6 equaling 2Z. Divide both sides by 2. And Z is going to equal 3. So you've used the AA similarity postulate, the angle-angle similarity postulate, to determine similarity of triangles, and then knowing once they're similar that their sides will be proportional, you've used that to solve for variables in the figure. This concludes the chapter 7.3 angle-angle similarity postulate. We'll now be moving in recording 2 to the other 2 similarity theorems.